Very good morning. Myself Arun Ranjan Naik, HOD Electrical in Nilachal Polytechnics. Now today I am going to explain regarding GTD subject, name of the chapter EHV, AC and DC transmission systems. This belongs to 4th semester electrical branch. EHV, AC and HVDC transmission systems. EHV, AC means extra high voltage alternating current. This decrease in load current results in following advantages. As current gets reduced, size and volume of conductor required also reduces for transmitting the same amount of power. The voltage drop in line 3 into IR reduces and hence voltage regulation of the line is improved. Line losses 3I square R gets reduced, which results in increase in transmission line efficiency. Some other advantages of extra high voltage transmission line are under power handling capacity of the line increases as we increase the transmission voltage. It is proportional to square of the operating voltage. Cost related to tower, insulators and different types of equipments are proportional to voltage rather than the square of the voltage. Thus, the net capital cost of transmission line decreases as voltage increases. Therefore, the large power can be transmitted with high voltage transmission lines economically. The total line cost of power per megawatt per kilometer decreases considerably. The operation of EHV-AC transmission system is simple, reliable and can be adopted easily. The lines can be easily tapped and extended. Next, disadvantage of high voltage transmission systems. The major problems in these systems are as under. First one, the corona loss is a big problem at higher voltage. This may further increase in bad weather conditions. It increases radio interference. The height of towers and insulation increases with increase in transmission voltage. The cost of different type of equipments and switchgear required for transmission increases with increase in transmission voltage. High voltage line produced electrostatic effect which are injurious to human beings and animals. Next, HVDC means high voltage DC transmission system. Under C cables where high capacitance causes additional AC losses. Around 25 to 50 km ballastic cable between Sweden and Germany. Endpoint to endpoint long haul buck power transmission without intermediate. Increasing the capacity of an existing power grid in situations where additional wires are difficult or expensive to install. Power transmission and stabilization between unsynchronized AC distribution systems. Connecting a remote generating plant to the distribution grid, for example, Nelson River bipolar. Stabilizing a predominantly AC power grid without increasing prospective short circuit current. Reducing line cost, HVDC needs fewer conductors as there is no need to support multiple phases. Also, thinner conductors can be used since HVDC does not suffer from the skin effect. Facilitate power transmission between different countries that use AC or differing voltage and or frequencies. Synchronize AC produced by renewable energy sources. Demerits. Circuit breaking is difficult in DC circuits. Therefore, the cost of DC circuit is high. The DC system does not have step up or step down transformers to change the voltage level. Next, the cost of converter station is very high in case of DC. Both AC and DC harmonics are generated. System control stability in HVDC system is quite difficult. Needs of high power transmission systems. This decrease in load current results in following advantage. As current reduced, size and volume of the conductor required to reduce for transmitting the same amount of power. Next, voltage drop in the line 3IR reduces and hence voltage regulation of the line is improved. Next, how does high voltage transmission works? The generators produce electricity which is then increased to high voltage by transformers and sent to transmission lines. The transmission system moves the electricity over long distances to local distribution systems where it is transformed to a lower voltage so it can be safely delivered to the consumers. Next, which type of running system is used for extra high voltage? Most of the transmission line in India is 400 kV. We also use 765 kV, highest in the world, for transmitting the electrical energy. Only 2 countries are there which are transmitting power above this voltage level, but these lines is under testing. The first one in India and second one in China. Advantages of EHV-AC transmission systems. The reduction in current power transmitted is given by, from the above expression, it can be seen that for the constant power and power factor, the load current is inversely proportional to the transmission voltage. With increase in transmission voltage, load current get reduced. Next, drawbacks of high voltage transmission systems. Interference. First one is interference in radio and TV which causes disturbances, may increase the cost. Third one is efficiently transported. Necessity of extra high voltage transmission systems. First one, the modern trends is to use extra high voltage EHV and ultra high voltage USB for transmission of huge blocks of power over long distances. The reasons for adopting of EHV or USB range for transmission purposes are given below. First one, reduction of electrical losses, increase in transmission efficiency, improvement of voltage regulations, and reduction in conductor material requirement. Second, economic consideration have led to construction of power stations of large capacity and so needy of transfer of bulk power over long distances arose. The transmission of bulk power from generating station to the load centers is technically and economically feasible only at voltages in the EHV and UHV range. The generating stations, particularly steam, hydro and nuclear power stations, are located in remote area far away from load centers. Because of the reason of economy, feasibility, and from the point of view of safety and environmental conditions, the EHV transmission is therefore inevitable for transmission of huge block of power over long distances from these power plants to the load centers. Next, flexibility of future system growth. There is flexibility of future system growth. Increase in transmission capacity of the line. The power transport is expressed as P is equal to Vs into Vr by X sin delta, where Vs and Vr are the two terminals and delta is the load angle, X is the line reactance. Thus, power transmission capacity of a transmission line increases with the increase in transmission voltage. No doubt, the cost of transmission line and terminal equipments also increases with increase in transmission voltage. But in general, these costs are proportional to transmission voltage rather than square of the transmission voltage. Moreover, there is also a saving in cost due to reduction in energy losses occurring in the transmission lines. As a consequence, the total cost of transmission decreases with increase in transmission voltage as depicted. This is the curve drawn between transmission voltage versus transmission cost. First one is, this one is the annual cost line is there, and second one is transmission line and terminal equipment cost versus transmission voltage. Third one is cost per energy losses. This is line will be shown in. This is the point for economic voltage level. Possibility of interconnection of power systems. It is practically not possible to have interconnection of two or more power systems, which is necessary to achieve sharing of installed reserves and for development of integrated systems and grids without EHV transmission. Increase of surge impedance loading. The load carrying capability of a line is usually expressed in terms of surge impedance loading, SIL. Surge impedance loading, or SIL, is the power that a line carries when each phase is terminated by a load equal to surge impedance of the line. Reduction in right of way. In some countries, right of ways are paid for at a rate proportional to total width of the transmission lines. Even in countries where right of way is not directly paid, there are usually strong pressure from a public requires fewer and fewer transmission lines, which the passage of time right of way becomes either more costly or difficult to obtain, and therefore it is becoming necessary to have few transmission lines operating at EHV or UHV. The worth nothing point here is that which the increase in operating voltage, number of circuits and requirements of land is reduced considerably. The worth nothing point here is that with the increase in operating voltage, number of circuits and requirement of land is reduced considerably. This is all about EHV AC and DC HVDC transmission systems.